So here we want to be able to solve a system of inequalities by graphing. And the first thing you want to check is how many rules are being applied. And we've got 3 rules that we're going to have to look at. So take each rule at a time and just make sure, are they in graphing format? So is y alone? If not, you'll have to do that first. So if I look at the first inequality, I can see that y is alone. It's a linear function, so we can see that we're going to have a y-intercept at 0, 2, and from that point we're going to be going down 1 unit and to the right 1 unit. We're also going to look at the inequality symbol, and that will tell us how we're going to connect our points. Since it's less than or equal to, the boundary points would be included, so we're going to have a solid line connecting those. Then, once you have the boundary done, we want to pick a test point that's not on it to see if it's true or false, and we always shade on the side that's true. So again, we could take our test point of 0, 0, put it back into the original inequality. Is 0 less than or equal to 2? That's true, so we're going to shade on the side with 0, 0. That's representing the region of solutions for our first inequality. Then we're going to do the second inequality rule, and we can see here it's the absolute value. And remember, the absolute value measures the distance away from 0. We can see a couple transformations happened. It was being reflected over the x-axis and moved up 4 units. So we could construct a table of values like we did first semester and do those 2 transformations and plot the points and make our boundary. Looking at the inequality symbol, we can see that they're included, so we're going to have a solid boundary line for absolute value function. So remember, if you're doing the transformations, reflecting it over the x-axis is taking the opposite of those outputs and then moving it up 4 units from where you had before, so taking the outputs plus 4. You graph the points on the outer 2 columns, so there's 1, 2, 3, 4, 5, 6 good ones that you could use if you're doing it that way. We also talked about how you could use your calculator's table of values feature to also find points that you can plot as well and create your boundary line for your function. As always, once you have the boundary line, we then have to pick a test point to see if it's true or false. So another good test point for us here would be 0, 0, because it's not on the boundary, and we substitute it into our original inequality. So is 0 less than or equal to the opposite of the absolute value of 0? Well, that's 0 units away from 0, and the opposite of 0 is just 0. 0 plus 4 is 4. So is 0 less than or equal to 4? That's true, so we're going to shade on the side with our test point. We have one more rule that we need to graph, and that's y is greater than or equal to x squared minus 7. This is a quadratic function. Remember, your quadratics are your parabolas, your u-shapes. And we can see the transformation that happened is moving it down 7 units. So again, like we did for the absolute value, we could do the table of the parent function for your quadratic and move it down 7 units from where it was before and plot those. You could also use the table feature on your calculator to generate potential points for your boundaries. We can see since it's greater than or equal to, again, we'll have a solid boundary for that rule. And again, you want to pick a test point that's not on the boundary to see your shading for the region of solutions. Again, 0, 0 would be a great test point because it's not on the boundary. Substituting it in is 0 greater than or equal to 0 minus 7, which is negative 7. So is 0 greater than or equal to negative 7? That's true, so we're going to shade on the side with 0, 0, which is within the boundaries of your parabola. Once you have all the rules graphed, you want to look for the solution area. That means where all the rules are true at the same place, same times. For us, I'm looking to see where is there blue, green, and orange at the same place, same time. Well, that's represented in each of the 4 quadrants. We do have a small section here in quadrant 1. We've got a section here in quadrant 2, 3, and 4. And because all of the boundaries were included, they're solids, we can use points on the boundaries that's forming that region. So in red is representing your solution area. So any point within that region or on your boundaries would work as a solution to your system of inequalities.